if you're sitting at a desk right now, maybe looking at a student's essay or reviewing a lesson plan and just wondering how much the landscape of learning is shifting under your feet, you are exactly who you're talking to today.
Yeah, absolutely. Because, we are exploring a shift that feels, well, entirely unprecedented. Suddenly, the machines on our desks are talking back,
Right. They're doing it with, like, astonishing fluency.
which is wild. It creates this illusion that we just, I don't know, crossed a magical threshold overnight. Like someone flipped a switch in a server farm somewhere and suddenly computers learned how to speak.
Yeah, but the truth is the machine you're talking to today didn't just appear out of nowhere. Today we're doing a deep dive into a 2,300-year-old intellectual family feud.
A feud that really explains why the AI on your screen behaves the exact way it does.
Exactly.
Yeah.
We are going to follow the path from classical Greek logic all the way to modern AI prompting. And we've got a really fascinating stack of sources for this. We're looking at historical addendums on the liberal arts, specifically this incredible piece titled The Great Divorce, along with Alan Turing's foundational papers and some essays on the philosophy of language.
And we should probably set the tone right away for everyone listening. This is not a story of smooth, inevitable technological progress. We are not doing a tech bro product launch today.
No, definitely not.
The history of how we got here is actually a story of a massive philosophical blunder. It's a dramatic reversal and honestly an ironic homecoming where the humanities, of all things, are returning to the absolute center of the technological age.
Right, which is just so counterintuitive. So let's unpack the beginning of that family feud, because to understand artificial intelligence, we have to start with the invention of formal thought itself.
Yeah, we have to go all the way back to ancient Greece, specifically Aristotle.
Yeah, Aristotle.
Right.
Long before anyone dreamed of silicon or copper wires.
Right. Aristotle basically wanted to identify the rules by which correct reasoning operated. He was trying to figure out what makes a logical argument actually hold water, so he created the syllogism.
Okay, and the classic example of that being, all men are mortal, Socrates is a man, therefore Socrates is mortal.
Exactly. And that simple structure is a monumental leap in human history, because Aristotle realized that the validity of an argument depends entirely on its structure, not its content.
So you could swap out men and Socrates for, like, dogs and Fido.
Yeah.
And the underlying pattern of valid inference remains exactly the same.
Yes, exactly. This was the founding act of abstraction. For the first time, human reasoning could be analyzed independently of whatever specific thing was being discussed.
So it's like he invented a mathematical formula, but for words.
That's a great way to put it. However, our sources point out a massive historical misconception here that we need to clear up.
Oh, right. There's this tempting, almost retrofitted narrative that Aristotle, by formalizing logic, took the very first step in, well, dehumanizing thought.
Right. People assume he started extracting reason from the human being so that it
Right.
could eventually be mechanized.
But that is totally false, isn't it?
That's a complete anachronism. Aristotle did not dehumanize reasoning at all. In fact, the very first sentence of his treatise on rhetoric declares that rhetoric is the antistrophos of dialectic, or logic.
Antistrophos meaning like a counterpart.
Counterparts, yeah. Two halves of a paired movement, like the left and right foot walking.
Oh, I like that image.
He didn't see logic as this cold, isolated math problem happening in a void. He saw rigorous logic and human persuasion as one unified project.
Right, and the mechanism he built to connect them was something he called the enthymeme.
Yes, the enthymeme.
Okay, I've heard that term. But how does an enthymeme actually work in practice? Like, how is it different from a regular syllogism?
Think of an enthymeme as a syllogism adapted for a real human audience. Instead of spelling out every single logical premise like a robot, you leave some steps unstated.
Because your audience shares certain cultural assumptions.
Exactly. You rely on the listener to supply the missing pieces. The listener literally completes the argument inside their own mind. So it is logic incarnated for an audience.
It's reasoning together. It requires empathy, really. You have to know who is listening to you.
You do. And for 1900 years, the classical and medieval worlds kept this unity intact. They institutionalized it as the trivium.
Right, the trivium. Grammar, logic, and rhetoric.
You learned how language worked, how to test the truth of a thought, and how to fit that truth to actual persons and occasions. They were an absolute package deal.
Until a very specific moment in the 16th century.
Yeah, this is where things take a turn. Our sources point to a professor in Paris named Peter Ramus as the true, unrecognized architect of the mechanical mind.
So what did Ramus do?
In the 1550s, Ramus carried out this surgical reorganization of the trivium. He took the substantive thinking parts of rhetoric invention, which is discovering arguments, and arrangement, which is ordering them, and he transferred them wholesale over to logic.
Wait, I need to pause you there. Why would a 16th century academic care so much about moving the furniture around of the curriculum? What was the practical effect of doing that?
Well, by moving invention and arrangement into logic, Ramus left rhetoric as just an empty husk. Rhetoric became merely about style, ornament, and delivery.
It just meant sounding pretty.
Exactly. He severed the diagram from the dialogue. If we connect this to the bigger picture, this Ramus severing was the required conceptual precondition for thinking of reasoning as something a machine could eventually do.
So to use an analogy, Ramus didn't just redecorate a syllabus. He evicted logic from the human household. He created this entirely new idea of audience-free reasoning.
Yes. To even dream that reasoning is something a machine could do, you first have to strip away the audience. You have to pretend that reasoning is an isolated process that can happen with no one listening.
Which Aristotle never granted.
Never. Ramus manufactured that premise.
Okay, so logic is now officially an orphan. It has been separated from the messy reality of human emotion and human audiences. And once that happens, the philosophers start to dream.
Oh, they definitely do. They start to think, well, if reasoning is just pure audience-free structure, maybe it can run entirely on its own.
And you see the mechanization of thought begin to take root almost immediately. Like, by the 17th century, Thomas Hobbes declares in his book Leviathan that reason is nothing but reckoning.
And he literally meant adding and subtracting. To Hobbes, thought is just computation.
Right. And then Gottfried Wilhelm Leibniz takes that to an even wilder extreme. He dreams up this characteristica universalis.
Which is such a fascinating concept.
It really is. It's this universal symbolic language where all human knowledge could be represented without the ambiguity of natural language. He imagined a future where two philosophers wouldn't even argue. They would just sit down with their symbols and say, let us calculate.
Yeah, let us calculate. Now, Leibniz didn't quite have the mathematics to pull it off, but that breakthrough arrived in the 19th century with a self-taught English schoolmaster named George Boole.
Boole, which gives us Boolean logic, the stuff powering the very device you are using to listen to this deep dive right now.
Exactly. Boole transformed logic into algebra. He showed that statements could be represented as symbols. The logical AND became multiplication, or became addition.
The universe was one and nothing was zero.
Right. Truth became something that could be manipulated through formal mathematical rules. Logic was no longer a verbal art, it was pure mathematics.
Okay, let's unpack this. So their goal wasn't actually to build a physical computer yet. They were just trying to mathematically eliminate ambiguity from human thought.
That is precisely it. They wanted to eliminate any trace of intuition or ambiguity. And by the early 20th century, mathematicians like Gottlob Frege and Bertrand Russell were trying to place all of mathematics on a perfectly rigorous, logical foundation. Complete formalization.
But let me challenge that for a second. Because trying to eliminate ambiguity from human thought, it's like trying to explain a sarcastic text message to someone using only a math equation.
Right.
It just doesn't compute. Human language is naturally ambiguous. Words have multiple meanings. Context matters heavily.
Yeah.
Boolean logic had to deliberately strip all of that context away just to function.
It absolutely did. And that mathematical hubris actually sets the stage for a spectacular failure. Because the attempt to perfectly formalize all mathematical thought hits an absolute hard limit.
The dream crashes into reality.
Big time. In 1928, the mathematician David Hilbert proposed the Entscheidungsproblem.
The decision problem.
Yes. He essentially asked, is there a mechanical procedure, like a universal algorithm, that can settle any mathematical question definitively? Can we build a rule book that solves everything?
And a young mathematician named Alan Turing answered that question in a landmark 1936 paper. But to prove whether such a universal algorithm existed, Turing first had to rigorously define what computation actually was.
Right, which is where we get the Turing machine. He imagined this hypothetical device. It had a limitless tape divided into squares, a head that could read and write symbols, just ones and zeros, and a finite number of, quote, states of mind.
He even theorized a universal computing machine that could simulate any other machine.
Yes, and earlier we mentioned a term from the sources, Gödel numbers, which I know sounds intimidating, but the concept is actually brilliant.
Oh yeah, explain the Gödel numbers because this is Wild.
So Turing figured out a way to turn every mechanical instruction into a unique number. It was like giving every command a mathematical barcode.
Which meant the machine could read its own instructions as data.
Exactly. But the punchline of Turing's 1936 paper was a proof that Hilbert's universal algorithm is impossible.
Wait, really? Impossible.
Mathematically impossible. Turing designed a hypothetical scenario where a machine is asked to evaluate another machine that is designed to do the exact opposite of what it's told. The logic just loops back on itself and crashes.
Oh.
He proved mathematically that there are problems that simply cannot be computed. There is no general mechanical process to solve everything.
Here's where it gets really interesting. This is the profound irony of the entire 2,300-year history. The computer wasn't the culmination of the dream of total mechanical reason. It was the child of its refutation.
Yes.
Turing invented the blueprint for the modern computer, the architecture of software itself, in the very act of proving what logic couldn't do. He built the machine just to prove a negative.
And right around the same time, you have Claude Shannon. He proved that Boole's logical algebra of ones and zeros mapped perfectly onto physical electrical relay circuits.
So a switch became a logical proposition. An open circuit is false. A closed circuit is true.
Suddenly, Aristotle's ancient insight that thought has a structure is made of physical copper wires. Logic is tangible.
So entering the second half of the 20th century, computer scientists are armed with Shannon's circuits and Turing's universal machine. And what do?
They attempt to fulfill that old Ramist dream. They try to encode human intelligence purely as mechanical logic.
This kicks off the era of symbolic AI. Good old-fashioned AI, as they call it.
Right. Researchers tried to build intelligence from the top down. They created these expert systems that attempted to encode human knowledge as thousands and thousands of explicit, logical, if-then rules.
Like, if the patient has a fever and the patient has a cough, then check for X.
Exactly. And it worked brilliantly for highly constrained environments like chess or proving mathematical theorems.
But when it came to the real world,
it failed dramatically.
So what does this all mean? Why did it fail? Let's dig into why, because this is crucial. Why couldn't a symbolic AI just recognize a picture of a cat?
Because the real world just doesn't fit into neat Boolean boxes. Think about the sheer mathematical impossibility of writing an if-then rule for every possible lighting condition, every angle, every fur color, every shape of an ear.
Right, if you try to define a cat logically, like has 4 legs, has a tail, has fur, what happens when the picture is a 3-legged cat? Or a hairless cat?
The brittle logic shatters. If you ask these systems to parse an ordinary human sentence or navigate basic common sense, they completely crashed.
So the 2,300-year logical tradition, when asked to actually replicate human language and perception, hit a brick wall.
A massive brick wall. And this failure caused 2 brutal AI winters. Decades where funding dried up, research stalled, and people really thought AI was a dead end.
Rigid, rule-based logic worked perfectly for mathematics, but it failed spectacularly at understanding human language.
Because human language is inherently ambiguous, context-heavy, and deeply rhetorical. It's full of idioms, shifting tones, and cultural implications. It relies on the listener to fill in the blanks.
Just like Aristotle's enthymeme?
Exactly like the enthymeme. Boolean logic was specifically designed by people like Leibniz and Boole to strip all of that away. You simply cannot capture the messy fluidity of language with a rigid set of true and false rules.
So if top-down math rules couldn't teach a machine to speak, the only option left was to completely flip the script. Stop giving it rules and just give it examples.
And that's exactly what happened. A completely different path emerged. Statistical machine learning.
Instead of programming explicit logical rules, researchers built neural networks.
Right. These are systems inspired by the structure of the brain that learn to identify patterns by being exposed to vast amounts of data. They don't use deduction, they use statistics.
Predicting the next most likely word based on billions of data points. And this is what leads directly to large language models, or LLMs, the AI we interact with today.
And the irony here is just incredible when you view it against the historical backdrop. Machines didn't become fluent because we finally finished formalizing language into perfect mathematical symbols. They succeeded because we gave up.
We stopped trying to formalize it.
We let the machine absorb the entire accumulated record of human thought, debate, persuasion, and story.
Every essay, every sermon, every unhinged argument on the internet. It's as if we spent 70 years trying to teach machines to speak by feeding them the dictionary and grammar manuals. But they only actually became intelligent when we forced them to read every letter, argument, and sermon ever written.
Embedded within all that human language are centuries of logical structures and rhetorical techniques. The machine learned to reason probabilistically by ingesting human rhetoric.
Which is mind-blowing.
It is. And because of this, the interface between humans and computers has completely shifted. For decades, you had to write strict code. You had to speak the machine's mathematical language. Now the interface is the prompt.
And the prompt is fundamentally a rhetorical act.
Yes. We are back to ordinary language. The divorce is over.
The classical canons of rhetoric actually map perfectly onto AI prompting, don't they?
They really do. Think about the 5 ancient canons. The first is invention discovering the available means of persuasion. In prompting, that's deciding what context, constraints, and angles you need to give the AI to generate the right response.
The second is arrangement organizing the argument. Anyone who uses AI knows that the sequence of your prompt completely changes the output. Instructions before content, or vice versa.
Exactly. The third is style, word choice, and tone. The model is incredibly sensitive to the framing, the persona you assign it, and the absolute precision of your words.
The memory is the fourth. Classical orators used memory palaces to keep their arguments straight. Today, we manage the AI's context window, making sure the relevant information stays in its active memory during a long chat.
And finally, delivery, presentation. Adapting the final output for the specific audience you are trying to reach.
It really is the trivium all over again. Grammar, logic, and rhetoric. The exact package deal Ramus tried to break apart.
And what's fascinating here is a concept our sources highlight called instrumental dissolution.
Okay, instrumental dissolution. Let's dig into that.
For 5,000 years, to produce a written document, a human had to do the physical and cognitive work of translating continuous thought into discrete sequential characters.
Like, you're losing me a bit with the academic phrasing. The philosopher Bernard Stiegler calls this grammatization in the source text. But are we just talking about the physical manual labor of typing on a keyboard?
It's the labor of typing, yes, but also the cognitive load of turning a complex web of ideas in your head into a straight line of text.
Ah, okay.
AI is absorbing that mechanical act. When you can speak a complex conceptual prompt to an AI and it instantly generates a structured, perfectly formatted document, the instrumental function of typing dissolves. The machine is doing the discretization of thought.
Okay, so the AI is handling the mechanical translation. But that doesn't mean human cognition is obsolete.
Not at all.
It means the human is freed up, or rather, forced to handle the higher-order rhetorical tasks. Invention, arrangement, and most importantly, verification.
You have to evaluate the output. You have to judge if it meets the need of the audience and the truth of the situation. We used to spend an hour doing the typing. Now we spend an hour doing the evaluating.
And if you lack the logical discipline to test those outputs for truth, or the rhetorical discipline to frame the prompt correctly in the first place, you aren't really collaborating with an AI.
You're just pulling the lever on a slot machine and hoping something good falls out.
Exactly. So bringing this historical journey full circle, especially for the educators listening to this deep dive right now, the path from Aristotle to AI is not a straight line of technological progress.
No, it is a circle. The machine age began by elevating logic and amputating rhetoric. Now the AI age has returned us to language.
But our sources make one thing very clear. This is not some shallow victory for the humanities where we just celebrate that machines can write passable poetry now.
Right, because rhetoric without logic is just manipulation.
The classical world knew this, which is why they taught the trivium as an integrated whole. The AI moment doesn't demand less logic, it demands a reunion.
The restoration of the Aristotelian whole, where rigorous, truth-seeking logic and audience-aware address operate together. You need the logic to verify the truth of what the machine generates, and the rhetoric to guide the machine's generation in the first place.
We spent 23 centuries teaching our machines pure logic. Now that they have finally absorbed it, they are forcing us to recover rhetoric.
It fundamentally changes how we think about preparing the next generation.
It really does. Which brings us to a lingering question. If collaborating with an AI is a rhetorical act of persuasion, arrangement, and judgment, are our modern computer science and STEM curricula teaching the wrong skills? We are pushing so hard for everyone to learn to code right at the exact moment when the machines are learning to speak English.
It is arguably the most critical question facing education today.
Perhaps the most important textbook for the programmers, the creators, and the knowledge workers of tomorrow isn't the Python coding manual at all. Maybe it's a 2,000-year-old treatise by Aristotle or Cicero. Something to chew on the next time you sit down at your keyboard. Or rather, the next time you start a conversation with the ghost in the machine.